to present to you guys the advanced technologies on our new EDX model. It is my pleasure to present to you our guest speaker, who is none other than Tan Tech Beng. So Tech Beng is from our regional office, the Shimadzu Asia Pacific, Singapore. So he has been providing application support, not only for XRF, but also for XRD, EPMA, SPM, and ESCE for the past 19 years in Shimadzu Asia Pacific. So he has conducted numerous application seminars like this and workshops on materials characterization, failure analysis, restriction of hazardous substances in many countries in the Asia Pacific region, including Philippines, Malaysia, Indonesia, Thailand, Myanmar, India, Vietnam, and Singapore. So currently, he is providing application and technical support for Shimadzu scientific instruments for more than 200 companies in the region. So without further ado, let's welcome Tech Beng. Tech Beng, please.
Okay, thank you, Laika, for introduction. So allow me to share my screen. Right. Very good afternoon to all of you. So today we'll be launching our EDX 7200. So basically, before I go into the launch and the details of these instruments, I would like to just maybe share with you some of the basics of EDX RF. All right. So basically, EDX RF itself, right, or stand for energy dispersive X-ray fluorescent. Right, so basically they are able to discern the energy of the X-rays that comes out, all right, from your sample as a result of you bombarding the sample with X-rays. So the X-rays that comes out, we call that fluorescent X-rays, right? So just a quick revision. Basically, X-rays is an electromagnetic radiation which we encounter in our daily life. You know, from our visible light, our ultraviolet lights, the infrared, the microwave, the radio wave, all these are electromagnetic radiation. But X-ray have very high frequency or very short wavelength. So it implies that the energy is very high, okay, that's short of the gamma rays. All right. So what happened when you interact X-ray with any materials? So what we are looking here is what we call the fluorescent X-ray that we are interested in. But I think many of you may be familiar with X-rays as in you go to a dental, they take a X-ray photography, or when you travel, maybe not so long ago, you put in your bag luggage, they can see what is inside without opening it, right? But here, what we do here is called fluorescent. Let me explain how it works. So basically, as I said just now, you basically shine X-ray onto your sample. So we know everything, the materials is made of atoms. So we can have a simplified structure of atoms where the electron orbiting around a nucleus with positive charge. So the thing here is that when X-ray hit a sample, because of the very high energy, is able to remove an electrons from the atoms. Okay, which other elements you have. Okay, so the first step is that this X-ray have enough energy to remove electrons, and not just any other electrons, inner shell electrons. Okay, so in all chemistry or reaction, we're always dealing with the so-called valence electron, that means the outer shell electrons, right? But in X-ray fluorescence, we are looking at the inner shell electrons. So the first part is actually to remove the inner shell electrons. And what happened is that this system become very unstable. So electron from the outer shell would go in to occupy the inner shell, okay, the vacancy there. So we know that there's a different energy between the outer shell electrons and the inner shell electrons. We also know that these orbitals or each of these shell have a fixed energy, okay. So that means that if valence electrons go into the inner shell electrons, they will have to release an energy that is equivalent to what the difference between these two orbitals, right? So if we measure the fluorescent X-rays, in fact, the energy is also very high. It comes out in the electromagnetic radiation, which is in the X-ray region. So if we measure the energy of X-rays or this fluorescent X-rays, we can know what is this element because every element have different configuration. Therefore, every element, when an electron from the outer shell goes into the inner shell, will emit a signature, an energy that is unique to only the elements. So our role here is to measure this, all right, X-ray that come up with, we call fluorescent X-rays. If we can measure the energy accurately, then we know what is this element. Okay, so this is what we call qualitative analysis. So it's a very simple, very so-called clean way of analyzing. Okay, and if we can know the intensity, how much X-ray comes out, we can know how much of this element is present. Right. So using this simple philosophy or this simple so-called process, we can actually measure. All right. So this is usually plot. The energy is plot on this graph here, a spectrum, and the intent across with the intensity on the y-axis. So from here, we can actually identify what elements is present. So if you look at the way you shine X-rays, you have a detector that detect and try to count the X-ray and separate out into different energies. So you can actually do qualitative and quantitative analysis. And you notice that this whole process itself is non-destructive. It only involves electrons. It's not like your AA or ICP whereby you need to excite it or you need to burn it, ionize it, and you get back your samples. Your sample is not destroyed or not harmed in any way. So it's a non-destructive analysis. So think of what you can do. And in fact, sensitivity is very good. Okay. So this is typically a spectrum that you get from an EDX. Okay. Right. And if you look at it, what are elements that you can analyze? Okay. Because apart from maybe those very small light elements, or we say low atomic numbers, in fact, most of elements can have this process. Okay. And in the desktop, we are talking about from sodium to uranium. Okay. In fact, you can do ATO elements. Okay. You 92 minus 10. You can do 82 elements. All right. So, and you have very good detection limits. Okay. Except for light elements, you probably get 100 or ppm. Most of them, you can go up to a single digit ppm or even sub ppm. Okay. So non-destructively, simultaneously within matters of seconds or even minutes, you can analyze. Okay. And down to very low detection limits. Okay. And non-destructive. So you can see why this is useful. Right? Why people actually use EDX. So because first thing, you do not have any restriction as the type of sample you're using. It can be a solid, it can be a powder, or even liquid samples. Okay. Even if you don't put any sample there, you just analyze air, you can see argon peaks because there's about point something percent argon in the air. So in fact, it's you can, as long as something that you can form, there's a certain form there, you can analyze it, non-destructive. And then most of the time, you do not need any chemical pre-treatment. If you want to do ICP or AA, you need to dissolve everything down to a solid, down to a liquid. And analysis is pretty fast, within seconds or minutes. And you have wide elemental range from sodium to uranium, in this case. And the elemental range is from part per million to 100%. Okay, maybe, and if you drag the analysis a bit longer, you can even go to ppb for the certain elements, which is possible. And don't forget, the good thing here is that you don't have to dilute your samples. You can go from ppm to 100%. That means you can analyze your sample and it is. Okay. And of course, the other thing here is that quantification. A lot of time we need quantification. Okay. And then again, most of the instrument will require you a standard sample in order to do some quantification. All right, so same in EDX, you can have standard samples, but what happens if you do not have standard samples, or you do not know what kind of standard samples, or what kind of samples matrix you have? Don't worry, you still can do quantification. Okay, so this is the good thing we call standardless. That means you can put anything inside, you can actually do analysis. Okay, elemental analysis performed readily. Okay, of course, you even have a standard sample you can do for quality controls and even much better, traceability for that. And of course, qualitative analysis is very straightforward. because every time you observe a peak, you look at the energy of that peak, you can use marker to straight away identify that, that's qualitative analysis. And if you look at it, this instrument is very compact. You can just put on the desktop. Okay, in fact, the power to run this is very minimum. I think it uses less power than your common desktop computer. Your desktop computer now probably require more power than EDX. Okay, so you can plug in directly into 3-pin plug, and because the X-ray is about 50 watt, you do not need water chiller. Unlike the big instrument like your XRD, whereby it's a few kilowatt, you need water to cool. This is all air cooled. Okay, so like I said, the structure consists of X-ray tube to analyze that and a detector to check the X-ray. But Shimadzu instrument is more than that. Okay, we actually have a CCD camera. That means you can take a picture, you can look at what you're analyzing. Okay, you have a collimator, okay, which you can control the size of the X-rays. This is very good for if you want to do so-called contamination analysis. And most important, we have this thing called primary filters. We have 5 built-in primary filters. Okay, and this can enhance the sensitivity and remove interference from your X-ray tube, which you can see here. Okay, all right, by putting a filters, because your X-ray tube is a rhodium tube, you usually have rhodium line interference, which we know interference coring. So by applying a filter, we can remove this interference line. And you can see that when you put a filter, appropriate filters, it actually lowers down the background and improves the signal to noise ratio. Another interference line being removed. So we have 5 filters that cover all the range of elements. Okay, so you can truly do sodium to uranium. Okay, just features here. We are looking at Shimadzu benchtop EDX with a 50 watt X-ray tube. This is the highest power for benchtop in the market, and you have built-in primary filters. We cover the whole range of spectrum. And we have cameras and collimators that is standard that comes with it. And of course, for some more specific application, we can also change the environment to a vacuum or helium purge. Well, which is required in some ASTM, you need a helium purge. And of course, the software that comes in is full suite. We give you everything there. There's no more you need about option, this option or that option. And you also can do thin film analysis as a standard. We also have database for material identification and matching. Okay, so these are the features that Shimadzu EDX always start with. Okay, and just before I launch, just give you a history of Shimadzu EDX. We have our first EDX 700, okay, in 1998, and the latest launch is in 2021. Along these 23 years or so, we have actually different models along the way. Okay, you can see. And we have been improving, all right, our instruments. And I'll say that the new EDX 7200, all right, we are not resting on our laurel, we are improving the best. In fact, the 7000 series launch about 7 years ago is one of the best instruments we have, all right, in the market. And we are also increasing the, okay, what are we going to improve? All right, in fact, we are in pursuit of the high sensitivity, high speed, and high accuracy, which apart from this, we also have a lot of features we'll explain about this latest EDX movement. Okay, look at what we have here. Okay, in fact, this is the most sensitive EDX developed by Shimadzu to date. Okay, when we talk about sensitivity, it means that how much count we can actually accumulate if we compare to our EDX 7000. Oh, sorry. All right, we have actually this is 7000, 3 times more count rate. And if we are older version, is 30 times more. That means 1 second of 7200 is equivalent to 3 seconds of analysis time by 7000, or 30 seconds by the older version. So with that, we can reduce analysis time significantly, 3 times over the last one, or 30 times over the other previous model. In fact, this have widened our gaps against our competitors, right? And the other thing here, maybe for people who are doing RoHS, okay? In fact, RoHS is restriction of high hazardous substances, is for screening. You know that all your electronics now, there is a certain, when you put a CE mark, it means that there shouldn't be the 5 hazardous substances like cadmium, mercury, lead, hexavalent chromium, and brominated flame retardant, PBB and PBDE. All right. So in fact, this regulation, as the year goes by, there are more regulation like halogen-free. People are interested now in COVID, and even antimony in Samsung, now even phosphorus and tin. So these are things that you can use EDX. You use it to screen easily, right? And we have a full support for that, all right? And screening software, we are making it so intelligent that any user can use it. You just put a sample there, okay? Even things like interference peaks of some peak in metals, we have this analytical intelligence system that can remove that automatically. And of course, most of the people I know here is come from academics or research. Maybe RoHS may not be your main application, but this EDX is not just for RoHS itself. Okay, there are so many options. Your sample can be anything from powder liquid, small samples, contamination studies, and so on and so forth. All right. Later I will introduce to you some application of this. So what it means by sensitivity, you can see that compared to 7,000 is 3 times faster. That means what use takes 300 seconds, you can do in 33 seconds. Or if you use the same timing, you get better results. Okay, the detection limit is actually the square root of root 3 better. So you can see this is the detection limit. And do note that detection limit depends on the time you analyze and the material. All right, here we use metal. Metal is usually the most difficult to get a good sensitivity, and still we can get a single-digit ppm. Okay, if you use plastic, you at 300 seconds, you easily go down to sub ppm, probably ppb level. Okay, especially for heavy metals. Okay, right. And then the other thing is that screening kit. All right, I think now we are more and more conscious about the things we put into our materials. All right, one of them is phosphorus and maybe organic tin. So this is required to screening. Okay, Shimadzu have this software that make it so easy that anyone can do this screening. I think in the past, you need to look at the spectrum and all that. Okay, so everything has been simplified using the screening kit. All you need to do is tick whether you want to screen it or you do not want to screen it. And you can just key in at what level of your control, how many ppm, because usually screening, we are divided into 3 regions, whether you pass, you fail, or in the gray zone. So you can just simply key in, and the software is intelligent enough to show you, okay, whether after analysis is passed or it failed, right? And the other things here is that we have this thing called the analytical intelligence, whereby we can simplify, because when we are doing screening, right, when we put a condition, we may say, okay, I set 100 seconds. But the thing is, many times, if the system detects that it's not present or it already fails, you do not have to analyze until 100 seconds. You can simply, okay, I'm very certain after 10 second or 15 second analysis, this thing confirm is below the threshold limit or above the threshold limit, I can go on. So we can have this thing called time reduction. The instrument is smart enough. Of course, this can be enabled automatically by you or disable if you prefer to run it the full timing. And of course, things like, interference peak can be judged by the software and can be removed by that. Okay, not to mention there are a lot of people here. I know that it's not just coming here for RoHS. You may be looking at cement, food, contaminations, pharmaceutical products, mining products. All this can be used using an instrument. Maybe if you are for electronics, you can also look at smaller area. You may want to do plating thickness also possible. Okay, so there is a wide range of option for the RoHS. Okay, and well, even for things like safety lamps, making it easier for you to prepare samples, these are all available here. Okay, with that, and of course the screening kit, right? This is the one that for the RoHS people, right? You no longer just have the RoHS, you can have the halogen-free 6-in-1, 7-in-1, and if you need additional phosphorus and tin, you can just buy one sample and you can just install it. You do not need to make one whole calibration curve. Okay, we have that everything pre-programmed for you. Okay, So in fact, we always say EDX 7000 720 is one EDX over all others. It means that we have one EDX that you can use for all the EDX application. All right. In fact, a lot of EDX in the market, they are very specific to only one thing. If you like to do oil analysis, maybe that's very good for it. You want to do another kind of analysis, okay, they are just for plating, they are just dedicated to plating. But Shimadzu EDX is one EDX, you can do every one of them. Okay, so this is the 7200. I am very proud to say we have launched this, and these are our latest flagship models. All right, so the next thing I want to go through is to try to explain to you. All right, maybe for those people who are not doing RoHS, this may be a bit dry for you, but nevertheless, let's have a look at how this thing will impact the RoHS advantage here. So I will just say that Shimadzu comes a long way in RoHS ever since the first generation. In fact, we are the first EDX, commercial EDX that is used for RoHS screening, was selected by Sony in 2002. It's almost like 20 years already, right? And since then, because the RoHS screening is basically a kind of application that share with many different applications, that is, the key is you must have good sensitivity. That means the better the count rate, the more sensitive instruments, right, the better you'll perform for RoHS screening, which is in any analysis, I will say that, no, if you have good sensitivity, that is always the case. So we can see over the years, we upgrade our X-ray to 50 watt. We start putting CCD and collimators as standard. These are not standard in all machines. Some machines do not have this. Then we upgrade our primary filters and detector with better count rate. All right. And then next, we think about how to make it easy for people. We come up with the world's first automatic screening software. That means it's become so easy that you just put your sample in, you press start, and they can straight away tell you whether it's RoHS compliant or not. It's that easy. Okay. Previously, you may not able to do so, but coming from GP onwards, in all our system, we have that. Of course, nowadays people go for liquid nitrogen free detector. All detector are non-liquid nitrogen. Okay. And of course, apart from just dedicated RoHS screening, okay, the most important part of all is you also can do other things. Okay, this is where the 7000 comes in, and it's one of the most popular model. And I believe with the 7200, whereby we make our software more intelligent, we have more support for all the type of screening kit and future-proof, it will continue to hold its place in the EDX itself. To date, we have more than 7,000 EDX already sold. All right, so this is a testimony of our system here. Okay, so if you look at why EDX, all right, the first thing is if you talk about RoHS screening, it's quick and reliable analysis. Okay, all right, because reliable, because it needs minimum sample preparation. It's quick because you just put it in, and it's very low running cost. You put your sample as it is. Most of the time, maybe you just need to maybe trim a bit or place it in the best position for analysis, right? And it's not destructive. Your user, easy to train user. If you know how to operate a computer, you know how to operate a mouse, all right, you can start using the software, take care of it. The Navi software, take care of it. Okay. And of course, RoHS may be 5 elements, inorganic elements, but if anytime you have future increase of things you need, it can be done. Okay. And you have other applications like film thickness, failure analysis, general material identification, all this can be done. Okay. So if you look at RoHS, what people want is this. Okay. This is the need. Okay. I think everybody will agree you want correct data to be obtained even by untrained operators in a factory option. You want condition to be standardized. Let's say if you're a company operating many companies in different countries, okay, you want that to be standardized. You want the machine to be able to only analyze when it's in the best condition, fully stabilized and all that. That means your data reliability. And of course, this I will show how it can be achieved. The other thing, you want your machine to be efficient and flexible. That means easy to operate. That means I don't need to spend long time training different operators, different shift, you have different operators, all can easily pick it up. So you can measure count of sample very fast. This is where the high count rate comes in. So if you have later on new elements that need to add in, you can. Okay, you can see that we have different screening kit available. So if you look at how 720 compared to 7000, is that we are 3 times higher count rate. That means you're going to get better results. Okay, meaning better sensitivity. You can analyze lower threshold, analysis time, more reliable data, and you have new screening kit. You have better time reduction function algorithm, removal of some peak, and of course, if you are using helium replacement, you actually uses less helium, almost half the helium that you use compared to a 7000. Okay, not to mention 720. Okay, if you look at 720, this is even way better. 30 times higher count rate, better detection resolution. You do not need liquid nitrogen. I think a lot of people complain because if you don't have liquid nitrogen, you cannot analyze. And the thing here, key thing is that this PC EDX navigation software, okay, and that is going to be a game changer in raw screening. I'll just look at it. Okay, you can see that compare is 30 times more. 1 second is about 30 seconds. Okay, you look at the detection limit. It's basically square root of 30. All right, the time saving. So you can see higher sensitivity. And this is where we talk about a gray zone. Okay, so in fact, in screening, that is we separate into pass, no good, and gray zone. So normally gray zone will also include so-called section contribution from your 3 sigma. That means from your instrument's precision. Okay, so if you have higher count rate, your gray zone, the 3 sigma will be smaller. So your gray zone will be smaller also. And not only that, your detection limit can be lower down. So for example, if I use my threshold, maybe I cannot detect anything less than 50 ppm with confidence. Okay, now with the new one, you can detect something maybe 30 ppm below with confidence. So you can actually lower this threshold. So this is very useful. Your safety margin, you can put in more safety margin, you can be more assured that you have less gray zone samples. Okay, and in terms of analysis time, okay, you definitely have, first of all, because higher count, you do not need like 300 seconds for one channel. You need it probably 100 seconds. And then if you set the time reduction function, this 100 seconds can be easily like 10, 15 seconds. Okay, so the whole analysis can be significantly reduced. A 20-minute sample usually take about maybe 2 minutes, sometimes in a 7000 or 7200. Okay, so come to the software. Okay, we will optimize this software. Okay, this software itself is so useful. It not only helps in the RoHS analysis, but in any general analysis. Why? Because the workflow, it simplifies the workflow from startup. Okay, you'll find that you've got okay, stabilization of the machine. If you need to do calibration, you need to check standards. Okay, is there any issue with calibration results? All this can be used. And if you are not turn on X-ray for a long time, they'll perform automatic aging to protect your hardware. Okay, you see, like for example, this is the old general analysis software, which is still present. For people who like to do this, use this, you can use. In fact, there are 2 software there, but this navigation software is very simple. Okay, it allows you to password protect. Okay, let's say you are not administrator, you don't want people to change the condition. When you do not key in the right password, you can still use the machine, but you cannot change the condition. So avoid people tampering with the condition. It's very good for in the factory kind of setup. So you can see when you first start up, they tell you, okay, initialize X-ray on. They'll give you a 15 minutes timer. So you can analyze until the machine stabilizes for 15 minutes. So you just follow. And analysis for RoHS is as simple as just putting a sample there. Okay. When you put a sample, you can see where your sample is. You can actually position your samples. And once you start, after finish, you can see the result. They can give you NG, meaning this is failed. All right. And not detected, or is it passed or okay. All right. If you want, all this, because in the past, you can't do that. Okay. In the past, without Navi, you need to first check what is this material, then choose a different condition for each one. Then finally, you decide yourself whether it's pass or fail. But all this in the Navi is one step, okay? And then because there is built-in calibration curve, and there's automatic selection of calibration curve, all done by the machine intelligence, okay? So you can see that if you choose the wrong curve, you get wrong results here, okay? All these things are automatically taken out by the software. Not only that, if your shape is not flat or not ideal, they also do a calibration automatic correct for you. Okay, if after you finish, you want a report, you can just one click, you can have report in either Excel form or HTML form. Okay, and if you want to do any calibration, is that you just put a appropriate sample, you measure, at the end, they'll tell you whether it's okay and which is not okay, whether you need to do recalibration, they'll prompt you. So this is very easy to maintain, very easy to operate. Okay, let's say if you have shut down this for a long period of time, when you turn on, they'll automatically age your sample so that your X-ray tube lifetime can be preserved. So I said you can standardize condition. Everything is very nicely standardized. You can pick different kind of the check sample for you. You are doing RoHS or even more. Okay, you can, as you can see with this, if you are new beginning to EDX, that software itself helps you. The workflow itself, okay, you can pick up very easy. You will not go wrong. Okay, if you need to have all these very important things like stabilization instrument, calibration, checks, identify issue with results, you know, which calibration curve to use for your samples, these are all built in the software. Okay, so not only that, like I said, this is not just RoHS, it's also built in for very advanced analysis. Okay, so if your other element of concern, you can do that. If you're high throughput, let's say you have many samples, you can put a turret, you can put 12 samples at one time, you key in it, and you start and automatically analyze. Sometimes certain elements, like allied elements, require you to use vacuum option, or some liquid analysis, you need that. And for contamination analysis, we can even goes down to the smallest 300 micron X-ray spot using a small spot kit. And if you have things like plating thickness, this can be done all using this EDX. In fact, the next session, I will just give you some example of the analysis that you can use using EDX. Okay, so you can see a lot of time it's just as simple. If you have powder sample, you put it in a cup, you just put it there, you can analyze. It's just that simple. Later in the video, you'll see how it can be done. Okay, let's say for example, okay, we have hydrogen sustain. You have seen now a hydrogen sustain just now for screening. What about those things dedicated one? For example, if you have standard sample, you can create for yourself. In this case, is there are standard samples that contain 8 of the control elements in toy EN71. Things like antimony, arsenic, barium, selenium. Okay, some of these are inside the RoHS. So you can actually use this to screen your toy or any other things. Okay, if you suspect things like there is a heavy metal in your soil or in environmental, your fly ash or all that, well, EDX can easily use it for EDX. Okay, so for example, liquid sample. Okay, for liquid sample, we'll usually prepare a cup. Okay, and it's up to you. You can do standardless, or in this case, we have a calibration curve, whereby we target certain elements. We want more accurate analysis and in the ppm level. Okay, the good thing about this, if you compare to AA or ICP, is that you do not need to make a calibration curve every time. Once you have this calibration curve, you can store that. You can use it for months. All you need is to verify whether it's still accurate or not. Okay, and it's very simple. Of course, the thing is maybe the sensitivity is slightly not as good. I know you can go easily PPB for other instruments, but the linearity range is much higher. If you're going from ppm to percentage level, you do not need to dilute your samples. Okay, so these are the good things that you can use EDX for. All right. So the other thing is powder sample. Powder sample, there are 2 ways. You can like put in the cup just now, which I show you, or you can press a pellet here. Okay. Normally, if you need light elements, it's more preferred to press as a pellet. All right. So You can see this is basically cement samples. All right, you can use that to analyze cement. Okay, if you have minerals, geological samples, like nickel mining and all that, you can grind it, you can press powder, or you can prepare glass bead as well. We have sold quite a few in Philippines for the mining sectors. Okay, right. So, well, what about if you have very little powder? Okay, little samples not available. You know, sometimes fly ash or your forensic samples are very minimum. So can you use it? Can you not only you can use it, can you calculate out with good accuracy? That's why we have this thing called background FP method. Because normally your sample need to fill up the collimator size, but if you have very little sample, sometimes you find your intensity is very small. All right, qualitative analysis is quite easy. You look at the peak position, but the intensity will fluctuate. So we have this thing called background FP method, which we patent to give you better and more accurate analysis results for quantification. Okay, and of course, foreign materials. Okay, this is where Shimadzu that collimators and the CCD come in. Okay, these are not standard in any machine. Okay, collimator means you can make the size of the X-rays smaller. We can go down to 300 microns option, or if not standard, it's 1 millimeter. So if you look at this sample here, you can see, oh, there is a spot here. So what is this spot? Okay, of course, you can pick it out and analyze it, right? But sometimes you cannot. So what you do is you analyze this using a small collimator, and you analyze the background. The background should have nothing. So you subtract the background. Okay, when you subtract the background, you get the results out. It's iron 68%, chromium 16%, molybdenum, manganese. So what is this? Of course, most people who know material, maybe metal, know this stainless steel, but you know stainless steel got different class. This is where we have a database. We can actually use this data to try to match from our database, which is the type of stainless steel. Is it 316, 304? The different classes. Okay, we have a database installed there, so you can do this. Okay, alternatively, this is another thing. This is actually for food, and it's very interesting. So they actually use a magnet, you know, or some sieve from your food. This is on food industry, and then they found this metal. So they analyze the stainless steel, and interestingly, they want to know whether it's what kind of stainless steel. Because if it's food grade 304 stainless steel, it most likely comes from their instrument processing. Okay, if it's other kind of stainless steel, maybe it's come from contamination from inside. So this probably 304 probably come from their instrument, so they probably have to check which part of your instrument have some maybe scratches or whatever to cause the instruments. All right, so cause this 304 to be there. All right, and not forgetting, well, there's another area that recently allows EDX to be used, and that is in the pharmaceutical. They have this thing called USP, a pharmacopoeia, or that 735-233. Is that as long as you can comply with their so-called validation, you can use it. And the good thing is that you can just put it in different samples and all that. You can actually measure impurities. Even if you're not complying USP 233 or 2735, you can still use your EDX to screen. Because the sensitivity is so good, you can screen it, and if you don't see anything, you know, you have a peace of mind. All right, you start from your raw ingredient first. You can screen the raw ingredients. Okay, but for final products, you probably want a 233 or compliance. Okay, you can do that. Okay, and not only that, if you have concern about food, okay, well, you can use EDX to screen. You know, you concern your milk powder may be tainted with heavy metals. Okay, don't worry, this is like 3,600 seconds. This is EDX 720. All right, the old machine. So you divide by 30. Okay, it's like a couple of minutes. It's not so long. And you look at that, this is down to ppb level. Okay, and you may think that, well, ICP can go down lower, but don't forget, when you analyze ICP, you dissolve this solid. And when you dissolve, your 1 ppb, maybe if you dilute 50 times, your 1 ppb is 50 ppb equivalent on a solid. So do know about dilution. So in fact, and you can analyze direct. Okay, no materials or analysis can let you do that. It's that simple. You can, you know, today if you you're afraid people spike your sugars or your curry powder or certain things that is heavy metal, you can just put it inside there and you can analyze, okay? Very fast, in a few minutes. If people want to poison you with arsenic, it's not going to be ppm. Then when you put it in, within seconds, you can see the peaks out. Okay, this is more for people doing electronics. There's some synergy here. At the same time, while you are doing RoHS, if you need to analyze plating, all right, this acts as a plating machine as well. Okay, and you can program it. Okay, and Shimadzu, software come as a standard. You do not need to order additional thing, but all you need to know is at least you must know what you're analyzing. For plating, you cannot say unknown. All right. You need to know what elements, how many layers. Okay, this is standard in any plating application, but you can do so. You can program your software to run it. Okay, finally, some interesting thing, all right, because this is elemental analysis, sometimes you can use that to identify fake, especially precious metal, because you want to make sure things is not destructive. But let's give a few examples. For example, this piece you can get like less than $5 in AliExpress. It looks like gold, all right, but we analyze there is gold, it's plating. Okay, the plating, you can actually use the software. I analyzed before, it's about a few nanometers. Okay, but of course, it come out like 1%, but it's not really 1%, it's much less than that. But basically, it's basically copper and nickel. Okay, all right, and sometimes people buy scrape. Okay, if you're somebody who buys scrape and people say, oh, these are silver. You look at it, oh, look like pure silver, but it's not pure silver, it's only plated silver. All right, again, if you look at it, it's 96% copper, but if you are not aware, you're going to pay the price for silver. Okay, all right, and this like, well, this one of my customers said, look at Yuan Bao, you know, those, you thought at least there's some silver. Yes, there's 2% of silver, but what is more scary is cadmium is 60%. So don't use your mouth to bite it. Okay, all right. And of course, a lot of old folks sometimes, oh, gold bell and all that, they're easily tricked, but they are not. So you can see. And what about precious stone? Okay, this is an example. Well, I just want to say the advantage of using our EDX is that we have primary filters which you can remove this peak, okay, because there's something called diffraction peak. And we know this source is a Burmese ruby, it's natural ruby. And of course, a lot of time red color doesn't mean ruby. There's a cheaper version called garnet, which have a lot of ions and all that. So ruby is basically aluminum oxide, same as sapphire, also aluminum oxide. The color is due to the type of impurities. If you analyze different areas, if you look at Thailand rubies, it will be more iron based because very deep color. Here, I just want to show you a synthetic rubies. Okay, basically, synthetic ruby is grown. Okay, depending on the process, a lot of time they use flux which contain molybdenum, which at the end of the day still left inside here. Okay, it's right, and of course, well, these are something maybe not everyone have it. It's quite called gunshot residue. We have this experience to run it in Thailand lab. So basically, you know, whenever you fire a gun, there's a powder, there'll be some residues left. Some of them is basically lead, barium, and antimony. If you find these three together, very likely this gunshot residue. Of course, when they sample, they usually say, oh, I swapped the thing. It can come in brown swap. And then they'll use ICP MS, not ICP. Yeah? Or sometimes they use a adhesive and they just stick on the gun. Then they see what is the powder there. Okay, and of course, here another sample is that I think this cloth is that they have a thing bullet went through. So I want to see, is there a bullet, why a residue left there? And finally, a piece of rock. Okay, I don't know how come these things. It's a piece of rock. It's like they actually got from there, like somebody find machine gun and a lot of deposit on that. So probably that was during in the south of Thailand. They get something there, right? And you can see that very easily. You just put a salt directly on the analysis and you start analyzing. You can see the antimony, the barium, and the lead easily. Okay. Well, and of course, when they tape on the gun, whether the gun had been fired before, if not fired, you probably will not get any residue. If it has just been recently fired, when you tape on it, you can get some powder there and you can analyze directly. Okay, and of course, this piece of thing quite interestingly, I think there is some lead and antimony. Maybe barium is very low, all right, because maybe let's go through it. But still, you can tell. And finally, a piece of rock inside there, and to find all this. Okay. Okay, and I think I just want to summarize this before going to the video. All right, EDX is basically an elemental analysis, non-destructive. So you do not need a lot of samples. If you have more samples, it's fine. If you only a little sample, you can use it. All right, you can determine the purity of raw materials for quality control as well as research. Okay, your sample can be solid, liquid, or powder. Okay, if you think certain drinks have been adulterated, fastest way, just put under analyze directly. If you put, some people put arsenic or some heavy metal content, you can easily do that. Okay, if you have finished product like stainless steel, you want to know what grade, aluminum, what grade, all these are in our database. Okay, you can analyze, you can match. Okay, if you want to compare different products, in nowadays, there are many companies who actually track their raw material or their products. For example, I get from this supplier A and supplier B, they say it's the same thing, but when I analyze, there's a different in elemental composition, or even the supplier that you get from. After some time, you want to check whether they're always getting the same because they also get from their other supplier. So they may tell you it's the same, but you don't know. Okay, this is what called silent change. A lot of factories actually wanted to check, because if you're using different products of different composition, you expect different quality. Okay, and most of the time it's not for better, it's always for worse, because it's cost cutting most of the time. Okay, if you want to contamination identification, things that you do not want to, you can use that. And trace analysis, especially heavy metals. Well, I think, of course, not only that, makeup, cosmetic, a lot of times, this is very easy. You just scrape the cosmetic cream or whatever, put it inside there, you can analyze for mercury, for heavy metals. This is much better than a handheld. The handheld system, XRF is only 4 watt of X-ray power. This is 50 watt. Okay, so expect better and more reliable result from here. And with this, finally, you can also do thin films. Maybe not everybody will use that, but it's something that you can do it using these instruments. And with that, I'll just end here and we can go to the video. Thank you very much for your attention. Right, back to you, Aika.
All right, so thank you, Tech Beng, for the very comprehensive discussion. So it is indeed a superb instrument that can be used for various applications and in different industry types. So actually, I've been receiving application-related questions already, but before that, so allow us first to give you a glimpse on how this new EDX works. So in fact, we just launched this new EDX last month, officially here in the Philippines, and you guys will be the first to see this demonstration video. So with that, let me now share the video. Okay.
excellence in science. Shimadzu.
All right, so that is how the new EDX 7200 works. Okay, so I think we can now proceed with the Q&A. Yeah. Or Tekbeng, do you have still anything to say about the video?
No, I think we can go to Q&A. I saw that it's good. I have 5 questions here. I'll try to answer them. And after that, if there's any question you want to ask, you can also just unmute yourself and ask. I think the first question here is this: how do you address repeatability issue in analyzing in different spot of the sample? Or is there a requirement for homogeneity of your sample? Okay, first of all, when you talk about repeatability, you're talking about sample repeatability means if you put different spots, okay, normally we want to know repeatability in terms of instruments repeatability. If instrument repeatability, we will analyze at the same spot. It's not different spot. If you talk about, if you produce different sample, you want to see repeatability, then you put different spot. But then when you do that, your assumption is that sample is homogeneous. If not, there is no meaning in doing that. You see, repeatability is trying to, okay, either you want to check how good is the machine, or you want to check how good is your product. Okay, if your product is not homogeneous, then there's no meaning in doing repeatability. You'll get results, all right? But it is nothing to talk about. The first assumption, if you want to use repeatability to look at how good is your product, you know, when you mix, how repeatable or how is the quality, okay? So that means your thing must be homogeneous, okay? But of course, when you compare, the machine repeatability must be better than the one that you want to find, because your repeatability is like, maybe you set a threshold, okay, high and low. How much is your so-called your criteria, all right? So this part itself, well, this is how I look at your question. If I didn't really answer that, or you want to add in, maybe later on you can unmute yourself and to further clarify. Okay. Next thing is primary filter consumable? If yes, what is the frequency of replacing? Okay, if you look at this slide here, okay, the primary filter is a piece of hardware. Okay, so this piece of hardware is basically you block the X-rays. Okay, so different material block the X-ray differently. As far as concerned, there is no need to change the primary filter, because X-ray does pass through it and you will not harm any of the things there. Okay, so ideally you do not need to change primary filters. Okay, you won't have any issue with that. Okay, unless somehow you open it up, you damage it, or you have, well, unlikely. Sometimes things go inside water, orange juice, or whatever, which if you accidentally spill, you damage the filter, then you need to replace that. If not, under normal operating condition, you will not need to change your primary filters. Okay. Hey, sorry, consumer, okay. So there's no frequency. And the third one is our EDX has no primary filter. What will the impact of that? Okay. Okay, the impact here is this. You will just function as a normal EDX, but you know, one of the things here is this. Your X-ray tube have a target. Most of the time is rhodium target. People use rhodium target because rhodium, this element, is very seldom used. Okay, because when you use rhodium target, whatever sample you analyze, you always have rhodium line. If you use a silver target X-ray tube, whatever sample you analyze, you always have silver. So if you see those rhodium line, in this case, if you do not have so-called primary filters, okay, this X-rays from an X-ray tube will come out on your spectrum. Right? So when it comes out of the spectrum, what happens is this. First of all, you are not sure whether this is real rhodium or not. Of course, you know many sample, there's no rhodium. But then if you analyze some elements that, for example, rhodium is chlorine, overlap with chlorine. So if you want to analyze trace level of chlorine, you may not be able to tell. Or if you really want to analyze trace level of rhodium, you don't know whether it comes from your X-ray tube or come from your sample. Right? So if you look at the primary filters, right, and where the X-ray comes in. So the X-rays will have rhodium line, but if you put a filter there, that filter can filter out your rhodium line. So whatever you receive here is come from a sample, not from an X-ray, right? So that is the impact of the first impact is that means that if you do not have primary filter, means when the instrument say from sodium to uranium, you cannot actually analyze all the elements because there will be interference. First thing, this interference. Second thing is that with a primary filter, you can see the same sample, the same peak, which have a better to signal to noise. That means if I use a filter, I may able to analyze lower concentration. My detection limit or sensitivity will improve, or detection limit will go down. All right, so this is very important. That's why in RoHS, which you are looking at trace element, primary filter is very important. In fact, it's a must. Okay, so that will be an impact. Of course, if you analyze jewelry, you'll see many multiple diffraction peak. Primary filters will help you to remove all this diffraction peak and let you able to identify your elements much better. So in fact, I would say primary filter is a very important piece of things inside your hardware itself. Okay, right. The next question is, since EDX is using X-ray radiation, are there any special PPE required during the operation? Right, PPE is not required. All right, and because I think every countries have a regulation. In fact, if you want to install X-rays inside, they need to certify, or we need to register that this is safe. We have a certificate of compliance, meaning that okay, first of all, this 50-watt X-ray tube is not so high power, and then we will submit certification that there's no X-ray leakage from that. And of course, the other part is that your agency also require the user to understand, okay, to go through a course, right? That X-ray is harmful if exposed directly, right? So first thing is instrument is very safe. So as long as no leakage, we have certified there's no leakage. And the other thing is user must use it properly. Okay, so when these two are being addressed sufficiently, there is no risk of this exposure to the X-rays. Okay, so the first question is, will we able to reproduce the result we obtained from old Shimadzu EDX to new EDX? Okay, I presume this is using the so-called for RoHS analysis. If for RoHS analysis, definitely you're able to, because RoHS analysis is doing screening, pass and fail. All right, so there shouldn't be any issue. In fact, the new EDX will make it better. Okay, but for other analysis is, well, because it depends on your condition. Because in if you are doing calibration curve, right, and you calibrate using the same sample on the old EDX and the new EDX, you're able to get the same results. In fact, I would say that new EDX results will be better because anytime you analyze a sample repeatability, there will be a standard deviation. Okay, the higher count rate of the new instrument ensure that your standard deviation, this fluctuation is smaller. If you use an old instrument, the fluctuation is bigger. Okay, but these two fluctuations should overlap. All right, by when we say reproduce, it means that you should able to get the same thing, because when God reproduce a result, there are a few things look into is accuracy and precision. Okay, the higher count rate, the better is your precision. Accuracy is, do you use the same style of standard sample to calibrate? If you use the same standard sample, you should basically get the same accuracy. Okay, so I hope I answer this 5 questions. If you have more questions, keep it coming. Either you type in or you unmute yourself. Okay, there are more things. can this be used to analyze trace element in water as well as major ions? Okay, it's basically an elemental analysis. Okay, regardless, we do not know whether it's a total elemental analysis. So whether it's in anion, cation, it doesn't matter. Okay, as long as in the element from sodium to uranium, we can analyze. Okay, yes, we can analyze trace element. In fact, well, of course, by trace is how much it trace. Okay, if you say want to go ppb, ppt, part per billion, part per trillion, maybe not. Okay, but ppm level, easily you can do it. All right, and okay, all element in the periodic table can be analyzed. No. Okay, so there are some constraints. One is instrument constraint, one is the technique constraint. Okay, basically XRF or X-ray fluorescence, you can analyze from beryllium to uranium. Okay, you look at the process, you have to remove the inner shell electron, and then you must have outer shell electron to fill in. All right, so if you go to lithium, you probably cannot have this process accomplished. Okay, then the next thing is theoretically, to have this kind of fluorescence process, you can go for atomic number 4, beryllium to uranium. But when you go to very small element or very light elements, the energy of the X-ray is very low, so it gets scattered. All right, so for a desktop XRF, all right, it's usually from carbon to uranium or sodium to uranium. Okay, and you have to use a vacuum option to analyze these light elements. Okay, if you want to analyze from beryllium to uranium, we have those 4 kilowatt system which Shimadzu have, XR 1800. You can actually analyze from beryllium to uranium. Okay, not all elements. Okay, minimum from element 4 beryllium to uranium, but then the instrument hardware will also determines what element you can analyze. So for this type of EDX RF, I would say is very common is sodium to uranium. And if you really want to analyze sodium, you need to have vacuum option available or helium option available. If you do not have this type of, if you just analyze in air, normally it's from aluminium to uranium. Okay, all right. So this is how I answer this. Okay, can this be used to analyze trace element in water as well as major ions? Okay, maybe the same question like sodium, magnesium, potassium, calcium, sulfur, and chlorine. Yes. But I would say the sensitivity will be different for sodium, and if you sodium, magnesium sensitivity will be worse. From potassium, calcium, sulfur onwards, and all this you probably can go in the ppm level. Okay, so and you have to take special care. For example, sodium, magnesium, these are we call low light elements or low atomic number elements. The energy of the X-rays that comes out, the fluorescent X-ray energy is very low. Okay, so you need to make sure your environment, you cannot run under air. Okay, you either have to run under vacuum or helium. So if it's a liquid, if you want to run under vacuum, you can use a filter paper method whereby you draw on the filter paper, you let it dry and analyze the residue. If you want to run as a liquid in a cup, you need to have this called helium replacement option. Again, we have this provided. It's an option. You can use past helium through it. Okay, not all instruments can support that. Right. So basically, the element like sodium, magnesium, potassium, all this is possible, but do check the concentration. Okay. What are the detection limit for uranium, thorium, and radium? Okay, I will say detection limit. First of all, detection limit actually depends. I will say okay. This will be in the ppm, low ppm, or even sub ppm. These are heavy metals. The energy of the X-rays can penetrate your air. You can run in air, you run in helium and vacuum. There's no difference because it's high energy. But the thing here is that your uranium in what type of matrix? Okay, because if you have uranium in normal ceramic matrix, because density is lower, or you have uranium in heavy matrix, like very high density material. Okay, then the sensitivity will be different. But also in general, your detection limit is all in the ppm level, or you can try it out. I think if you put analysis slightly longer, it should be sub ppm. It's possible. Are there any restriction or special handling instruction for analyzing sample with high salt content? We can cause corrosion. No, not really, because salt itself is basically an element by itself, right? We are not. This is not ICP. All right, that's why you do not need to dilute or whatever. You analyze the material as it is. Okay, marine sediment which are dry. Okay, so I think you can, if marine sediment, I would say that maybe some preparation is that you need to grind it to homogenize it. All right, and either you homogenize it, you can put inside a cup or press as a pellet. Okay, and you can analyze direct. Okay, this is for that. But of course, we can always look into. I think one of the things that Shimadzu is that we are here to support you in the application as well. Okay, we have Shimadzu 7000. Can we use this for SC determination? SC, I believe you're talking about scantium. Yeah, not an issue. You can analyze scantium easily. Limit shown in project is for which matrix, like solid? Okay, that one that I show you is for liquid samples. Okay. This is generally liquid samples. Okay, all right. Yeah, this is a very good question because your sample, if it's a solid or heavy matrix, it may be different. But certain thing we can change is the analysis time. Okay, every time we, if you want to halve the detection limit, we have to increase the analysis time by 2 square. Or you want to divide by 3, analysis time go by 3 square. Okay, that's an inverse square relationship there. Okay, X-ray tube and detector warranty, how many years? Okay, X-ray tube and detector in an instrument warranty is always 1 year, right? So unless you have extended warranty, which that will depend on how your contract with SPC, right? But generally, instrument all come 1 year warranty. But what I want to say here is that in Shimadzu X-ray tube is, if you buy X-ray tube for OEM, even they say warranty 1 year. If you spoil it at 6 months, you claim, they will not give you full claim. They only give you like 20-30%. If you're on the 11th month, your things spoil, you only can claim back like 5% of the value. But in Shimadzu, when we say we warranty a whole year, means it's a 1-to-1 X-ray to exchange. But I will say that in general, if your condition in your lab, you goes by the installation, you don't have high humidity, our X-ray tube on the average can last maybe 3 years or more. Okay, this is not a guarantee, but this is what we observe. Okay, some places we have seen X-ray tube used for 5-7 years. Okay, and no problem, right? Can you analyze accurate amount of mineral like calcium, magnesium in multivitamin mineral tablets or syrup? Okay, if you want accurate, yes, you can. Like, if you want accurate, you need to ensure that you also make sure you have some proper calibration, okay, and make sure your sample preparation is consistent, okay. So, well, multivitamin, you're talking about milligrams. It's possible, all right. Of course, you should be able to detect, or syrups. Yep, I think we can do that. Magnesium, probably you have to be a bit careful. You need, because it's light elements, you probably cannot run in air. Okay, you need environmental control, right? For calcium, manganese, iron is pretty straightforward. They go into ppm level easily in air. Okay, right. I hope I answer everything. If there's anything, do feel free. You can unmute yourself, or those things that I didn't clarify. You want to for any one of this question, please. You can unmute yourself, right? Okay, if not, I'll back to you, Laika.
Yeah, actually, Bank. So we have a good number of questions, and the discussion was great. And I'm afraid that we cannot accommodate the other questions. But if ever that you still have other clarifications, so I am also displaying the email address of TechBank as well as mine. So you can send us a message. You can send us an email anytime you want. If ever you have questions regarding the new EDX as well as other Shimadzu products. All right.
Again, thank you, Tan, for this wonderful presentation and for giving us launching our EDX 7200 or 7200. And here is our key message to our dear partners. One, this is regarding our EDX 7200. Of course, one is the value of money. The new EDX 7200 is packed with far greater feature than our previous models. And best part is that Shimadzu is currently retaining its old price or same price, having a lot of features, sensitivity, better sensitivity. Of course, with some negotiation with Shimadzu, same price. Of course, same price will be given. Hindi po siya nagtaas. Normally, new model comes out, of course, price increase. But this time, Shimadzu is giving us the same old price. Number two, industry-leading specification. Shimadzu EDX 7200 surpassed expectations with better sensitivity, resolution, superior performance versus competition. Of course, we have better competition. We have a lot of competitors of EDX, but we believe our Shimadzu EDX has now a better sensitivity and etc. compared with them. Number three, wide application capability. Shimadzu EDX 7200 is able to meet the demands of several applications and industry-related analysis. One, from hazardous substance, forensics, pharma, RoHS application, mining, metal sorting, university research, environmental, and many, many more. So marami pong application ng EDX 7200. Let's use it and let's experiment on it. And rest assured, it would be most useful in your lab. And of course, number four, Shimadzu is a reliable partner. Shimadzu has been here for more than 30 years or even more. And Shimadzu Philippines Corporation is a subsidiary of the manufacturer that has capability of technical support. We have demonstration unit and experience after sales to safeguard our investment. So narito po ang Shimadzu bilang subsidiary, and of course, most of you knows Shimadzu, and we're here to stay being a subsidiary of the manufacturer itself, Shimadzu Corporation. With this, of course, next slide, please. We have a replacement promo for machine, EDX 720 or even EDX 7000. If you want to have it replaced, we have a replacement promo of any old EDX, whether it's Shimadzu or not. Please feel free to contact us or email us at sales@shimadzu.com.ph. With this, thank you very much to everyone who's been here.
So thank you, Sir Roque. So guys, this is our promo. Again, we have a replacement promo for old energy dispersive X-ray fluorescence spectrometer. So this applies to both Shimadzu and non-Shimadzu brands. So for any requests for quotations, for any inquiries, so you may send an email to sales@shimadzu.com.ph. Again, you may send an email to sales@shimadzu.com.ph. So for more Shimadzu webinars, you can access those in Shimadzu digital classrooms, wherein Shimadzu now allows you to learn at your own pace and convenience, anytime, anywhere, because it is an innovative tool that is packed with Shimadzu webinars, both live and recorded, on various analytical technologies, applications, solutions, flow of information, and compliances. And for more information regarding Shimadzu products and services, so just visit our official LinkedIn page and Facebook pages. Just search Shimadzu Philippines Corporation. And feel free to send us a message if you have any inquiries. So all our webinar announcements, product updates, all are posted there. And then just this year, we launched our YouTube channel. You may subscribe, please, and watch a number of videos featuring Shimadzu products and applications. And actually, some of our webinar recordings are already uploaded there, and more updates are yet to come. So this marks the end of our session for today. Thank you everyone for participating. Thank you to TechBank for being our guest speaker today. So thank you to our colleagues from Shimadzu Asia Pacific Singapore and Shimadzu Philippines. So thank you everyone, and we look forward to your usual support in our succeeding webinars and virtual events and other marketing activities in the future. So thank you again and enjoy the rest of the day. So keep safe everyone, please, until the next virtual event.
All right, thank you. Bye.
Bye, TechBank. Thank you.
Thank you.
Excellence in science. Shimadzu.